Good morning, my name is Marco Emerja. I'm Chief Architect in the Networking Group, and I'm here to talk about the SD-WAN solution that we've developed.
Good, SD-WAN. I like SD-WAN.
Oh, you're excited. Excellent.
I was excited about load balance. I have a love-hate relationship with load balancers.
So as an architect, I'm much more comfortable sitting at the table and talking rather than being up here and talking, so please ask questions during the presentation. It'd be greatly appreciated. So to start with, I want to talk a little bit about the trends that we saw when we were starting to develop the product. Basically that enterprise traffic is doubling every 3 years. More and more apps are coming from the internet. So SaaS is now 50% of apps used in enterprise. More and more data centers are now being moved out of on-premise into the cloud. So basically that the WAN was going hybrid. And that the value of the network was actually getting higher because apps were being pulled out of the known locations in the branch or in the data center and now being moved remotely. So that the cost of an outage was even higher than it was before. And the value to the business of the network is higher than it has ever been. So against that backdrop, we've been developing the SD-WAN solution. So we had a couple design tenets that we said, the solution must be about the application. First and foremost, it's about delivering the app to a user. Whether we're talking about Skype for Business and being able to have a nice, clear video and audio call, or Citrix XenApp VDI type of solution, it's about the user experience and making sure that the user not only has access to the application, but that it performs well. Then it's about, as we talked about before, resilience of the network. It has to stay up. Even, we have more and more, ever more complex networks. We need to be able to make sure that they stay up and are of good quality. And then central control. So SD-WAN, part of the name, as the name implies, we basically built a controller. It manages the entire network. It updates the software. It controls everything from one central location. We haven't figured out how to do the actual plugging of the ports remotely, but we're working on that. So there are 4 main components in our SD-WAN solution. Sort of path aggregation, where we bond the links together, the actual resiliency that we built into the network, the ability to look into the network and understand what's going on, and then the ability to optimize the applications flowing over the network. So enough with the market talk now. How does the solution work? At the very base data plane layer, we're taking a bunch of disparate links and we're bonding them into one logical virtual WAN. That virtual WAN can be optionally encrypted with IPsec, but basically the value of that bonding is that whether you have one big FTP or lots and lots of little connections, it acts like one big virtual pipe. So that one FTP can take all the bandwidth of all the links all at once, if it needed to, or you can have thousands of different connections running over lots of different links. But the administrator, once it's bonded, doesn't have to think about those things. On top of that, through the addition of our other little minion WAN optimization, we've added a layer of optimization. Layer of optimization on top of the SD-WAN, so that we can then optimize on top of our transport the applications that are running on top of it. So things like TCP termination to be able to deal with high latency links, data compression and deduplication, so that those file transfers only have to go over the network once rather than back and forth. We also optimize the delivery of audio through quality of service, as well as video through caching and pre-positioning, so that those training videos don't have to be pulled down in the morning and affect everyone in a branch. And then all this is delivered in a single branch appliance. So we're simplifying the deployment at the branch. We're not talking multiple boxes, multiple stack of things that we have to manage remotely. So how does it work? Sort of at its basic premise, you tell the system, what business policies do you want to enforce? Skype for Business is my most important app, and my XenApp traffic is my next most important app. Everything else is secondary to that. You can tell it about links. I have 4G LTE as my tertiary backup. Make sure that I only use, it's usage based. I pay by the byte. So maybe only use that in a case of last resort, or if everything else is down. Or at least be sensitive to its usage and tell me if you're using it because things are going, I want to be aware that I'm going to end up paying more. We then map that with the application needs. So if an application like Skype or VoIP, they tend to want a low jitter, low latency link. Packet loss is slightly less important because they can deal with that inherently. Whereas when we're talking about FTP, we want to know that, FTP would rather have a big pipe, big packets, and no loss so that we don't have to deal with retransmits and stalls in the transfer. We combine that with our application acceleration, and then we basically can deliver those applications effectively over the network. So how we do that? Actually, any questions up to this? Okay. So I like to make the analogy of traffic. It used to be when I got up to go to work in the morning, I would get in my car, get on Highway 17, and usually that would work, but then sometimes I would come to a complete stop and I'd be like, why is it stopped? I turn on the radio, listen to the traffic report. Oh, there's an accident on Highway 17, and now I try and figure out, is there an alternate route? How do I get to work today? Now it's a little bit easier with the help of our modern little technologies, smartphones. We have things like Waze. Waze, now I go and get in my car, I push the button, it says, here are your 3 routes to work, here's your expected ETA, here's what you can expect along your route, how much traffic there is, and I can make an intelligent decision before I leave or before I get stuck on the highway. So we took some of that philosophy when we built SD-WAN. So what we did is, typically you'll have, more than 2 sites, but let's say you have 2 sites and a number of links in between them. What Virtual WAN does, it takes all those links and bonds them together in what we call a virtual path. So logically, there's one link. What we're doing on the packets traversing this network is that we tag every packet with a sequence number and a high-resolution timestamp. So when the packet gets to the other side, I know not only did I get it, did I lose a packet, did it arrive out of order, and I have good accuracy with regards to latency and jitter of that packet relative to other traffic on the same link or other links. So with that information, I can make an intelligent decision as to what traffic to put on what link at one time. So the other aspect is, one level deeper, we measure everything unidirectionally. So on this virtual path, from this branch, there are 6 possible paths I can take to get to the other side. I measure inbound and outbound because traffic is asymmetric. If traffic is coming from the data center and VDI, I'm getting, my video remoting. On the upstream, I'm just sending keyboard and mouse clicks. The actual network technology might be asymmetric as well. DSL or cable modem technology, where my upstream is much less than my downstream. So when we measure and we're mapping things, we can say, let's say I have a Skype for Business call, I'm putting it on the MPLS, because at this moment in time, it's the most appropriate link for that traffic. It's going along fine, all of a sudden, because I'm measuring every packet, I can see a trend or in the change in network attributes over time. So in as few as 3 or 4 packets, I can see the jitter is now going up on the MPLS. And so I can make a decision. That MPLS is not serving my application's needs, and I can move it transparently to another link. The user doesn't experience any change because the virtual path as an entity is still up, and I'm sending the package to the other side. Neither end notices a difference, but I've now transparently moved those packets onto another link. Somewhat unique because, I show sort of an outage here. An outage is a lot easier to detect because all of a sudden packets just don't go through. The typical demo where we unplug something is kind of, not that interesting because you can easily detect that. What's harder to detect is these brownout conditions where links become of lesser quality and they're not serving the application well. That's where our solution is unique. So, as I mentioned, we then layer the other minion, the protocol acceleration, on top of this secure substrate. And in this case, we do things, because we're application aware, we do things like protocol optimizations where we reduce the amount of chattiness of certain applications as they traverse the WAN. You know, CIFS was famous for being extremely chatty, and even though it's gotten better in the subsequent releases, there are still optimizations that we do to be able to benefit the user by reducing the amount of chatter back and forth over the network. As well as, because we're application aware and protocol aware, we can actually distinguish between header and data. So when the guy sends a PowerPoint, like we were doing last night, this one, in email to several users in a branch, and one guy uploads it to SharePoint, the other guy saves it to his network share, and the third guy sends it via email again with some modifications, we can find that PowerPoint and send only the delta changes of that thing. And so we're very efficient with regards to the utilization of the network. And then the
Can you
last
dive into that for a second? I'm curious at a deeper level how you're doing that. So you're saying you're essentially deduplication of traffic by recognizing some form factor of this file, but those three things you mentioned would have happened at different times. Like, I mean, like how long are you talking about having those types of fingerprints around and not deduplicating that data?
Should have left the other slide in. I had a slide on exactly that, but basically, we depending on the size of the box, we have three different types of compression. We have sort of what we call first pass compression, where it's just, okay, I've never seen this data before, I have no fingerprints anywhere about it, I'll just do an LZS or a gzip or some other first pass compression. I then have the boxes, depending on the capability of the box, has a certain amount of main memory where we'll do another set of, that's where we'll store deduplication, our fingerprints for that. Even on the branch boxes, we have a tertiary store. So for long matches, typically greater than 1 megabyte, we will move them into the disk stores because they're high value, i.e. we think we'll have a bigger match. How long that lasts depends on the size of the link relative to the size of the box that's there. But our boxes run up to, Carl, refresh my memory, how many terabytes of data? 5 terabytes at the high end. So again, it's sort of how much traffic that we care about are we looking at versus the disk space, but it can be a very long time. We typically would say, back in the day, we would say days, if not weeks, depending on the bandwidth of the branch and the size of the box.
And I'm assuming this is down to some block level.
Yes. So I talked about the application knowledge is really about understanding the header data split, understanding what, in a file transfer, let's say, what is the file? So we'll focus on that file when we're doing CIFS, whereas the header data we'll mark it and say, this is probably not relevant or is a smaller match. Mm-hmm. So that helps us be more efficient about what we store on disk.
Okay. So you're in the middle of encrypted streams as well?
We can. So we do SSL decryption or man in the middle type of decoding to do that, and then all the rest of it applies. When we do that, we must be given the certificate at the server side. The certificate never traverses the network. We negotiate the keys at the server side and then send the symmetric key for that connection to the other side.
Yep.
So the private key is not at branch, so then you don't need FIPS compliance hardware.
So, FIPS compliance in it. So we have FIPS compliant crypto. Actually, we have FIPS certified crypto. We are not a FIPS certified platform.
Right.
When we're doing the WAN optimization, the system would be difficult to FIPS certify because that key is moving outside the boundary would have to be the system.
And the thing is, with SMB3, we don't call it CIFS anymore. Right.
Okay.
With SMB3, you're talking about encrypted Microsoft traffic, so that's very hard to get in the middle of reliably.
Yeah. So on the server, the way we saw that, we joined the server side of the network to the domain, so that he can then basically impersonate the user. You can make a delegate user, so that he can then get the credentials on behalf of that user and both sign and decrypt those streams.
And SMB3 is way more efficient than SMB2.
Correct.
Right? So SMB2, this local ACK technology, it's been around for a decade or more.
Correct. So yeah,
We don't need it in SMB3 because a lot of the Microsoft stupids have been taken out.
Most of them, I agree completely, have been taken out. There's still some little optimizations, especially with regards to large directories and things. But yes, it is very corner case now on the SMB3. Completely agree.
Yeah.
But you'd be surprised how much SMB 1 and 2 we still see in the field.
Oh yeah, well, you know.
Yeah, it's a long tail there.
Yeah.
But yes.
Enterprise IT and Microsoft. Too much stupid in a single planet, really.
Can you give us some more details? How are you handling, if you, in your example, you had 3 links?
Yeah.
How do you store one fat pipe across the 3 links? For example, you have different latency on these 3 links. How do you distribute this session? Yeah.
Yeah. So I'm measuring. Actually, this slide. So I'm measuring every path, right? So I know latency loss and jitter in every direction on each of those links. So, and each of those links has a bandwidth that I'm either configured with or calculate dynamically. Based on that, I make a decision, and the application comes in. So I now have a packet for FTP. FTP likes high packet rate or high bandwidth and low loss. Doesn't really care about latency. So let's just for the moment say that's equal priority to a voice call, just to make the example simpler. The internet has great bandwidth, and for the moment at this time has no loss. So but its jitter is terrible, and maybe the latency is kind of bad. I'll put it on that one because it has tons of bandwidth. That voice call that comes in at the same priority, well, this link has low jitter, but has a little bit of loss. Let's just, for the sake of example, say that. I'll put it on this one because it's best. The voice call wants the lowest jitter possible, so you get clarity of voice and the best monster. So that's how I'll make the decision.
My question would be, can you distribute one session across 3 links?
Yes, you can. So let's take the one big FTP so I'll start on the best link. If it exceeds, if I get more traffic than that link can handle, I will start scheduling onto another link. And then the way the scheduling works is I'm trying one more layer of depth. So we have actually control messages that come back from the other side. So I know from the other side how much he can accept and on which links. And so I will start, and because I know the latency on each link, I can schedule how many packets I need to put on one and the other to approximately expect them to arrive at the other side in order. I have a little bit of a jitter buffer on the other side to make sure they are delivered in order. But yeah, I can actually spread the packets across multiple links and still get them mostly in order on the other side. 99.5% of the time they'll arrive in order at the other side. And then I take care of any issues in my jitter buffer on the other side.
Okay. How big is your jitter buffer?
I knew I was going to get that question. I don't remember off the top of my head. So, but the goal is to never add more than a few milliseconds of latency. So that it's probably more measured in time than it is in number of packets.
Well, yeah, big is
so
really referring to how long it is.
Yeah, I want to say it's less than 5 milliseconds, but I'd have to go back and check. I don't remember.
Because some applications, it might be fine to have 100 milliseconds or so, and other applications, 5 is the number.
Yeah, we rely on, so our goal is we rely on the scheduling up front, like I said, for 99 I pulled out 5 as a random number, but most of the time to get stuff in order. The jitter buffer is there to deal with variations that while the network changes while I'm sending a certain packet. So, but yeah, we can, though I don't know if we do right now, we can, on a per application basis, change the size of the buffer for our QoS. So I imagine that we could extend that into the jitter buffer as well.
So your scheduling is based on the conditions of your links, what you know you have available, so that they can all be delivered around the right order.
Correct.
And that's on a per app basis, or are those apps like, is it per class? So within a class you schedule that way, or?
Well, yeah, basically I schedule, so I try and keep packets in order. I get them in, I send them out in order. Yes, I do schedule within a class. So I have 3 broad classes and lots of subclasses between them. But generally speaking, I'm scheduling within one of the big classes.
Okay. And if you have, or in case some packet loss of one of these links, then the packets will be resended from the buffer of your box?
Yes. So we actually have a couple modes of operation. One mode is best effort. We just send and whatever happens. We do have a reliable transmit mode where we will transmit from our buffer and say, if the other side misses the sequence number, he'll send us a message and we'll retransmit to avoid TCP backing off. We also have another mode where we can actually send packets down multiple streams to make, so that we get to the other side guaranteed. So like FedEx, if you absolutely positively have to get that packet across. So, no more questions,
So, do you automatically figure out, you said you had 3 major traffic classes?
Yeah.
So you're looking at the applications and deciding which kind of traffic goes into which class?
Correct.
Do we have any control over that? Or?
Yes, so that was as part of the configuration. We have a set of presets, like, I don't know, call it 200 plus applications, but you can change their priority, you can get down into the HF, the hierarchical fair service curve attributes if you really want to. We don't recommend it, but you can do it and do that. But yeah, typically most people use the defaults. Yeah. So, one of the other tenets is centralized control and management of the system. So, we rack and stack, we support zero-touch deployments, but like I said, you do have to actually plug the box in at the remote site. From that point on, you can control the system remotely from our virtual WAN center, configure software updates, manage the whole lifecycle of the box. And then for visibility, which I think we'll get into a little bit more, we share AppFlow or IP fixed record generation with NetScaler. So we generate information about the packets and flows going over the WAN. They can be consumed by third-party products as well as our own Insight Center products. And then we can produce reports that show hop by hop what is happening in the network. This is an example of HDX Insight where this is a view that's available through our desktop director, which is our help desk product for our XenApp and Zen desktop virtualization products. If you get a call from the branch saying, "Hey, my Outlook is performing poorly," well, if it's being delivered over HDX, you've got lots of applications inside that HDX stream. So typical network analysis tools don't do much there because it looks like one protocol. We can parse it out, get user, application, and the different latencies and round trip types between each of the links that go across each of the segments that are delivering that user's stream. So in this case, we can see that there's something going on in the branch, but they're getting 81 milliseconds of latency. This is actually trying to represent a use case we actually debugged without HDX Insight at the time, where they were saying, "Oh, we have horrible latency." Everyone tends to point at the WAN because LAN don't lose packets on either side. They tend to be very reliable. Well, unfortunately, that was a Wi-Fi access point that was overloaded in one branch, causing queuing and packet drops and terrible latency. Of course, it took us a lot longer to find without HDX Insight. But it's not just only about the VDI applications. Obviously, there's hundreds of other applications that run over the WANs. So we basically do AppFlow record generation for all those apps, and we can see who's using what applications in what branches, how much are they consuming, what is the service level that they're receiving in terms of the end-to-end performance of that application. I'm trying to speed things up since I know I'm running out of time. So we basically have 4 main benefits, efficient use of the network resources and the ability to contain costs as those networks must get bigger to accommodate more traffic. We can bond commodity internet type of links with your MPLS to make it much better. Through that resilient multi-pathing or virtual path, we can keep the branch up no matter what the network conditions. If one or more links go down, we're essentially RAID for WAN links. So just like you could put a bunch of this inside a RAID chassis and make it highly reliable, i.e. greater than the sum of its parts, we can do the same for the WAN. We provide an excellent user experience, both with our underlying substrate as well as the application optimizations. And then we give the customer flexibility to deploy quickly and even bring up, as this demo was supposed to show, a branch with just LTE links and bonding them together and give you a reliable, quick branch, which we're actually using for this live cast right now.
Should I just pull it up now?
So yeah, so if we're going to switch to a quick video demo instead of our on-site demo.
What we have done over the last decade is we have systematically taken everything that's of importance and we have put it on the other side of the line. So now this line needs to be much more thicker. I need to have much more bandwidth in my link, and it needs to be much more stronger and resilient. No matter what, I need a line, especially when I'm trying to conduct business, I need a line that's going to withstand all tests. I need a line that's going to be there. So instead of talking about it, why don't I show some of this to you? I have with me over here Shoaib. Shoaib, what do we have here?
Well, we have the entire Citrix story right here. On this laptop, I'm in a XenApp session, and I am launching a published Skype application. And then this is going to use the HDX real-time optimization pack. And I'm going to use that to call Scott, who's obviously at a remote location. And we're seamlessly and securely delivering this solution across our SD-WAN technology.
Good morning, Shoaib. How are you? Hey, I understand you're working on the network today.
Hey, Scott, I'm doing great. We actually just finished implementing SD-WAN to leverage both our primary MPLS as well as our broadband internet link. And we're actually delivering this video call across both links simultaneously.
Well, whatever you're doing, this looks really good. The video is really crisp on my end.
Yeah, buddy, it's cutting-edge technology.
Really? Cutting-edge technology? Well, I have some cutting-edge technology of my own over here. What do we have here? Bunch of cables?
Yeah,
should I
you can
cut one
take
of
your
them?
pick.
Let's cut the blue one.
Okay.
No.
This is our blue
No.
cable running to our primary MPLS.
It's cut. What's happened?
Scott, are you still there?
Just kidding, just kidding. I'm still here.
You got me with that.
That's not.
This is fun, man. I want to cut the other one too. What will happen if I cut the other one? Let's cut it.
This white one runs to our broadband internet.
No, please don't, please. Oh.
Wait a second. How did that?
Wow.
How did that happen?
Yeah, well, the
Do you have
connection
magic?
stays up and active. What we did was we set up a backup last resort 4G connection. So now Skype runs across that.
I see. Now I have with me a hammer.
Well, let's save that for next year's demo.
All right. Thanks, Shoaib.
No problem.
That's awesome. That is awesome.
You can't take Abhishek anywhere. He wants to break stuff.